Hello everyone, in this video I'm going to continue the Solow model. As I said in the previous videos, in this model basically explores the factors that affect an economy to grow over the long run. This model has basically three main factors. The first one is basically the saving rate, the second is population rate, and the third is technological change. Okay, so any change in the saving rate is expected to affect the economy to grow over the long run. Any change in the population, and implicitly you can say it's labor, right? We say population, but they basically explore the impact of labor. How labor, the increase in or the growth in labor is going to affect the economy to grow over the long run. And the third factor is technological change, which could be like a positive change or a negative change. Okay, so what we did in the previous video, we basically explored the first factor, the saving, right? And we, just a reminder, we said that the saving ratio multiplied times output, or we can write it as a function of K, and you can refer to the previous video if you kind of forgot or you want to refresh your mind, minus the depreciation rate times the capital labor ratio. If this positive effect, which we call investment, so you can call this whole thing investment, if this positive effect is equal to the negative effect, which you can call depreciation, so whatever you're adding to the economy in terms of investment is equal to whatever you subtract from this economy in terms of depreciation of capital, then if these two forces are equal, then we can say that the change in capital labor ratio is equal to zero. And this is the point that we call steady state. Okay, so this is what we left at in the previous video. In this video, I'm going to go over the second factor. How can we include this second factor into this model, which we call the population growth, or as I told you, can say it's the labor force growth. Okay, so I want you to think about anytime I'm saying, or in your textbook, we keep saying change in K, and we say K is simply the capital to, I'm writing it's capital to labor ratio. I want you to understand, or this is called the change because I have a delta here, so it's basically the change. So if you write it as K, then this is the capital labor ratio. You can also think about it as this one. It's K over L. It's the capital labor ratio. So every time we are talking in this model, we're saying K, this is basically the capital to labor ratio. Okay, so we keep talking about this variable, and implicitly we actually mean K over L, which is capital over labor. And it makes sense to understand that anytime the K increases, which is capital, whatever you're adding to the economy in terms of capital stock increases, then this would also increase economic growth, right? In other words, as K increases, capital stock increases, the capital labor ratio increases. Of course, I should add one sentence: as capital stock increases holding labor constant, then the capital labor ratio increases. Also, as you can see that this one is in the denominator. So given that the L, right, which is the labor force, is in the denominator, then anytime I have an increase in L holding this variable constant, then the capital labor ratio would decrease. Okay? So you can write it this way. So you basically can say that as capital stock increases, then capital to labor ratio would increase. And then I want you to add here in between bracket, holding everything else constant. Okay, in your principles of macro, we used to say, or principles of economics in general, we keep saying holding everything else constant, and we have this Latin word, and we say ceteris paribus condition. So you can holding everything else constant, and everything else we have here is just L constant. Okay, then capital labor ratio would increase. Also, as labor force increases, it's in the denominator, and again, just repeat this sentence in between brackets here, holding K constant, then this would imply that capital over labor decreases. So that means anytime you have more and more people, right, more and more workers, you keep dividing this K on more and more people, right? You keep dividing this K on more and more workers. And this is the idea of diluting. Okay, you have dilution. You keep spreading out capital over more and more workers. Okay, so in your textbook, and we have this word which is called dilution. And dilution basically is the growth of the labor force times K. In other words, what is the required growth in the labor force in order to maintain the amount of capital stock that we have? So if you still remember this equation, we keep saying that in order to keep the change in capital labor ratio constant, we need the positive effect, which is investment, minus the negative effect, which is depreciation, right, equal to 0. And we call this as the break even point. Okay, so it's the break even point, or we call it steady state. It's the point of equilibrium. Okay, so now we're going to add something else to this equation. You can actually rewrite it as, you already know this. So when you say investment, okay, which is basically the I, which is the small fraction s times fk, right? So you can write it as small fraction times f of k minus, we used to say that we have dk, which is the depreciation ratio times capital labor ratio. Now we have to add to this equation n, which is the dilution, k. Dilution is nk, or it's the labor force times k, or basically it's the amount of growth in labor force that is required to maintain capital. So you can actually rewrite it as SFK, right, minus D plus NK. Okay, so in other words, investment is, which is the positive effect here, is we subtract out of it depreciation plus the dilution rate, depreciation rate and dilution rate out of capital to labor ratio. In other words, we need to update our steady state by these two forces. And again, if these two forces are equal, the positive effect is equal to the negative effect, then we can say that we have the kind of updated steady state. Okay, so we can see this in a graph, and the graph, you have it on your textbook, and I'm going to show it to you here. So when you look at this graph, and this one has actually the same points that we have discussed previously, and it's basically we have discussed the point at which investment is equal to, like the original point that we did discuss. I'm going to use like a blue color. Okay, so if you imagine that this was our point that we did discuss, which is the point at which actually, you know what, we haven't discussed this one because we didn't have the n before, so I just don't want to. Okay, so let's imagine that you have an intersection point. Okay, so this intersection point is happening at K1 star, in which investment, you can write investment as the saving ratio times output, okay, is intersected with depreciation ratio multiplied times capital to labor ratio, and then we're adding to it the growth in the labor force multiplied times K, and both together will give you the dilution ratio. Okay, and then we need to see what's the effect of the increase in N. So if you follow the 1, 2, 3 boxes here, the increase in the labor force growth makes the break-even investment line steeper. So as I told you in the previous video, the increase in any, or the change in any of these letters like N, K, S, F, K would change either the intercept or the slope of the line. So this is one of the cases in which you have a change in the slope. So as you can see, the point, because of the increase in the labor force from N1 to N2, then we have a shift upwards, right, in the line that represents depreciation and dilution. So the break-even investment would change. So what we're gonna have is a new intersection point. So instead of having this intersection point, we will have a new intersection point, and it makes sense that it's like less than the previous, than the first one, which is K1 star, because we have a negative impact on our change of K. So the change in K was equal to investment, right, minus D plus N K. And what we have here is a change in the N. The change in the N has a negative sign in the front, so it makes sense that the change in capital would be, right, or capital would go even small, it would become even smaller. Okay, so we have a drop in capital labor ratio from K1 star to K2 star. And this would be like the new break-even investment. Okay, all right, I'm going to stop here, and then the next video we're going to discuss the third factor affecting the steady state.